In this example, I need to find the exact value of, in part A, the inverse tangent of 1. So quickly reviewing the inverse tangent function, the input values, or the domain, is the set of all real numbers, and the output value, or the range, are angles in the interval -π/2 to π/2, but not including the two endpoints. So what this means is I'm looking for an angle somewhere in the shaded region here on my unit circle. So I could have a positive angle rotating somewhere between 0 and π/2, or a negative angle rotating from 0 to -π/2. When you first start working on these problems, it's often easier to set the inverse trig function equal to a variable. I like to pick theta since we're looking for an angle. And then I just translate what this statement means here. This means that the tangent of theta equals +1, and don't forget the restriction, theta has to lie in the interval -π/2 to π/2. These restrictions on theta mean my angle has to lie either in quadrant 1 or in quadrant 4. Now I'm looking for the tangent of theta to equal a positive number. Remember, the tangent of theta is sine theta divided by cosine theta, and taking information from the unit circle, this means it's the y-coordinate on the unit circle divided by the x-coordinate on the unit circle. For the tangent to be a positive number, that means the x and the y coordinates have to have the same sign. That is true in quadrant 1, but it's not true in quadrant 4. Therefore, I know my angle has to lie in quadrant 1. As the tangent of theta equals +1, this means the x and the y coordinates have to be identical. And when does that occur in quadrant 1? It occurs right here, where the x and the y coordinate are both the square root of 2 divided by 2. Here's the angle that produces that result. So I know that the inverse tangent of +1 equals π/4, or if I'm in degrees, 45 degrees. So this is the answer to part A. Now in part B, we have a very similar problem. I need to find the exact value of the inverse tangent of -1. So again, we're going to set that equal to a variable theta, translate this statement. That means that the tangent of theta equals -1, and don't forget the restrictions, and theta must lie in the interval -π/2 to π/2. So theta has to either lie again in quadrant 1 or quadrant 4. As the tangent of theta equals a negative number, it means the x and the y coordinates have to be opposite in sign. That is definitely not true in quadrant 1, but it is true in quadrant 4. So my angle has to lie in quadrant 4. And since the tangent of theta equals -1, it means my x and y coordinates have to have opposite signs but the same absolute value. That is true at this point here, where the x-coordinate is the square root of 2/2 and the y-coordinate is negative the square root of 2/2. So this is the angle that produces that result. but be careful. When your answer is in quadrant 4, I cannot say my angle is 7 pi over 4 because that does not lie in this range. What I have to do is find the angle that rotates in the negative direction to get to this point. After a while, you'll be able to figure that out in your head, what that negative angle is. But to start with, the simplest thing to do is to say that theta equals 7 pi over 4, and then just subtract 1 complete revolution of 2 pi radians. And then as you have a fraction and a whole number, turn the whole number into a fraction by dividing it by 1. I need a common denominator of 4, so I'm going to have to multiply numerator and denominator by 4. So I get 7 pi over 4 minus 2 times 4 is 8 pi over 4. So that is 7 pi minus 8 pi is negative 1 pi, or just negative pi over 4. So I know that the inverse tangent of negative 1 is negative pi over 4, or if you have to be in degrees, negative 45 degrees. So be careful when you have an inverse tangent and the argument is negative. The answer is going to be in quadrant 4, but you have to make sure you find the negative angle that rotates to that point.